Khushbu ma'am, are you there?
Yes, Dr. Salim, I'm here. Actually, I'm searching one file to get it
Okay,
open.
okay, fine.
So I just
I thought you were speaking and your mic is mute.
no.
That's why I was confirming. Okay, thank
Yeah,
you.
I'll be back within a couple of minutes.
Yeah, no problem, ma'am. Yeah.
Yeah, I'm just sharing my screen. Let me know, Dr. Salim, are you there?
Yes, ma'am. I'm here only. Yeah, your screen is visible.
Yeah, it's visible, no?
Yeah.
Salim sir, I have a request with you that
Yeah.
if I think you are having this model, no? That file I have sent you earlier means.
Yeah. Let me search it. Yes.
Yes, if you can keep this as ready so that we can show them the communication protocol using the real-time emulator.
Okay. Let me find it out. Till then, you can please demonstrate. Till then,
Yeah,
I'm finding
till
out.
then,
Yeah.
yeah, till then I'm doing that.
Yeah, please.
Thank you.
Welcome, ma'am.
So regarding the communication protocol, you have already heard. Actually, here I'm already running the test for Typhoon test IDE, that is for the EV. So that will take couple of more minutes. So this is the Typhoon test ID. As the test report will be generated, I'll be explaining and going through all these things. But meanwhile, till these reports get open, till then we can go through some other conceptual points which we are using means practically in our field. So that I'm going to discuss you right now. So regarding the communication protocol part, here you have had a number of communication protocols. We are having like C37 where we can perform the PMU receive and PMU send. And then we have the CAN. Actually, we just completed the things for this EV part. So how do we use this CAN for this EV part? How we are using this CAN communication protocol while communicating the signals between the ECUs, that is electronic control units. How do we do that? A little bit idea I'm going to give you. Then the most important other protocols like industrial, we are using Modbus device we are using for the communication protocol is especially in the respect of when we are working on the microgrid and moving ahead with the smart grid regarding the energy storage management system or like that. So these things which we are using nowadays in a very much uh, demanded way. those who are working on distributed energy management system, so they are using Modbus and Modbus subspec in that respect. So in that respect, we do have some model also. So here, this is just a temporary model where we haven't designed any control units with this model, only tried to use EV as a DER source here. And this is a kind of, you can say, a smart grid, because we have involved very smarter things for this, like communication protocol we have used to in order to communicate between this grid and residential load in PV inverter and EV and all. So that I'll be letting you know, because the thing is that with this Typhoon test ID, if I have opened this Typhoon test ID, I cannot open SCADA. So both these points cannot be opened at the both end. So let me finish with this Typhoon test ID, then I'll come back to this SCADA of this particular example. Till then, we can explore a few points, like about when I'm talking about this communication protocol. Hope it is visible to each and everyone. So this is a communication uh, protocol, that is controller area network. So in our electric vehicle, we are having different electronic control units, or we can say that inside one electronic control unit, or the nodes which is defined, that is the definition given to the number of electronic units we are having. Now, how these electronic units will communicate? Suppose, like when the airbag has to get open, how would the signal will get? And if there is, like in our this smarter EVs, we are getting the uh, notifications or something like a beep sound of things. For like if somebody is passing through and even we are not on the steering, then also that is handled by this electronic control units. So for this purpose, we are using CAN, and CAN we are also using that flexible data also we are using, like CAN FD has been came into the picture. So this is the way you can see that different ECU units are here, and with this different ECU units, here you can find that different colorful connections you can find. So these colorful connections interpret, like we are using yellow color interpret low interior CAN bus, then something blue line that indicates your high speed underhood canvas, then green indicates the powertrain high speed can. So this is, then we have the dedicated safety system like high speed can, that is in the red color, and then we have the limbus like this. Now the purpose of using this particular colors of this is that to reduce the noise whenever our motor or something means it is running, so it is means containing some sort of a noise. So what happens when we use the uh, CAN bus that is at the lower side and CAN bus that is at the full means high CAN bus, and that is also in the form of a twisted wire cable when we are using. So that is calculating the difference, and difference should be, means suppose a particular low CAN bus is at 2 and high CAN bus is at 3. So difference is 1. So that should equate the difference. For that purpose, we use the twisted cable for the communication part in this CAN. So this is about the controller area network. How do we implement in EV? When we go in vast, it will become much more vaster. So in a very short way, that how we are implementing CAN, that is the controller area network, in controlling our ECUs network, controlling the length, controlling the data. And here there is one more thing, like if we can pass only 8 bytes of data, means per CAN, if we are using that, we can pass 8 bytes of data. Suppose if you are having 10 bytes, so what you will do, you have to use 2 CAN, that is one CAN for 8 byte and another for the 2 bytes data that you can send. But means if you want to select, means a full data 10 bytes to be sent at through only one single. So CAN is not the appropriate option for that, and we are not opting for other communication protocols as well, because when we are sending the signals or the data in this particular byte, like suppose I am sending 10 bytes through some other communication protocol, so what happens, the message or data which is sent, that is not acknowledged, that is not means it will be sent, and if even if the data is lost, we are unknown of these factors. So in order to avoid these factors, we are using it is better to use two CAN. You can use if you are communicating through the data of means like if you are sending the data more than 8 bytes. So of course there are many electronic control units, so that each electronic control unit would have a node. This is a report is generating the Typhoon test ID which we had run. We will just come back to this later on. So that particular different ECUs will form the node, and this is a kind of a network. You can see that how it is creating that, the speed with which speed it will go for different types of CAN bus. We have provided that, and how much data and how much length we can go, that is there. So regarding this, we are having one example also in our schematic, that is the CAN bus loop. So inside the CAN bus loop, you will be able to see like this is a kind of a CAN setup. And for this CAN setup, we are using one CAN bus send and CAN bus receive. In our office, we are having only HIL 402 box. So with that 402 box, it is not possible for us to use the communication protocol CAN. But for Modbus, we can show that could be run. So that's why I asked Dr. Salim to have this. So inside the CAN protocol, when you will look inside the CAN, so here you can understand that this is the HIL device ID as we are connected to one device ID. Here if I will show in the model settings part. So inside this model settings part, you can see that one HIL device 604 and configuration ID is 1. As your counting starts from 0, so that's why it is showing HIL ID 0. Now about the baud rate and these parts. So when we are talking about all these baud rate, that is the bits per second in which we are including these parts, I'll come back to you with the baud rates also. So we are keeping the baud rate and execution rate for all these CAN bus and receive in the proper, means in the same scenario. If I'll click on that, I'll show you here. Can you see this? This is the CAN controller, CAN1. We have used the dialog window, and message ID we have given 1000, and this is for the 11-bit normal that is keeping up. And data length has told you that we cannot take greater than 8 bytes. So it is 6 bytes we have taken. So for each signal, it is showing the start bit and the length bit in the form and on timer. So this is what matters. The main thing you have to go through this part. These are the signals which accordingly you can adjust the way you are using. Similarly, in CAN receive also you can see the message ID is same, that is 1000, and the data length is 6. So when I tell that we have, if we are having a network that is n number of ECUs, and then we are connected through some sort of a CAN bus that is also terminated through a resistor that is a resistor that is a 120 ohm. Okay, 120 ohm that is terminated through a resistance, that is CAN high bus, and CAN low bus is terminated through 120 ohm resistance. So that type of a network is called a CAN network. Okay. Now regarding to this, like if some network CAN high bus has speed like 500 kbps and CAN low has 200 kbps, then all the ECUs which are connected to the CAN have to be configured to the 200 kbps. Means to the minimum one we'll have to be configured in order to get the proper difference which we can get. So that is the point to be noted, that when if we are having some configuration, like suppose the same thing we have done here, the given message ID, given data length, that is here. Similarly, the baud rate which we kept, that is the 50,000, there it is given. So that means that will be for uh, altogether it is 50,000. For can 1 also we have given the baud rate bits per second, and can 2 also we have given the same 50,000 baud rate. So this is the kind of setup which you can perform using the CAN protocol, means CAN communication protocol. It is just an idea inside this, because even if we simulate, so it will require the real-time emulation, because in our boxes we, in our higher 6 series, and in fact in the 4th generation 4 series, we are having this communication protocol, so we can go through these tests, but currently we do not have in office that particular box. I also do have, I would like to show you one more example regarding the microgrids, because as per the participants, I was able to find that all are interested more in means this microgrid part. So here one model is there regarding the multi-protocol uh, microgrid example. Even you can open on your window also. So here, as it was told earlier, that each generic component is having their own user interface. Now, the purpose of user interface, you already know, like suppose if you want to make it a little bit smarter, like for PV plant, we have used this RTU, which is the remote terminal unit, which is the user interface of power plant. But here we had made the modification. What the modification I have made? See here, are you getting any component like that you can unlink or something? You are not getting here, but I will show you. There you will get, because here it is already unlinked. This part is already unlinked. So suppose taking for PV only, to just mention you the difference. So this is the interface for the PV plant. Now here I get the component, unlinked component. But in our example, it is not showing because that component is already unlinked, and by unlinking the component, what they have done, they have used the Modbus communication protocol. I just show you. This is the Modbus communication protocol they have inserted, which will help to communicate that whatever the power measure, reactive power, apparent power, and it could be communicated, and that could be, the data could be sent using this Sunspec Modbus device. So you can also use this, means you can utilize your communication protocol inside this user interface. Similarly, for battery energy storage system, one example you are seeing here, it is used CAN communication protocol, the same way which I have told you. So here they have used two CAN. Why they have used two CAN and two CAN send? Because the data may be greater than 8 bytes. So here you can find it is already, the data length is 8 bytes. So for this CAN send and CAN receive, we are using one pair. Okay. And another CAN we are using, that is also having the data bytes for 8. And here also you can see the data bytes, it is 8 for receiving. So for receiver, for the send and receiver, this message ID, you can observe that for the second part we have differentiated the message ID using 1001, and for the first setup we use the message ID 1000 for both of them. So this is common for all these. Now inside this part, when you will find that about the communication protocol which we are using, how we are assigning the signals. So here you can understand the signal that enable which we are giving, that is 8 bits we are giving, converters for starting bit is 8 bit, whatever the converters we are using. Then regarding the reactive power or reactive power, about the alarms if you're using. So many things, so many signals you can involve. Similarly in EV, when we are working on ECU, so all these factors come into the mind, and according to the signal information, we can include these signal information as we have used here for the battery energy storage. And here what we are trying to see, that how much the means the storage provide, the capacity of the battery which we can give to the uh, means converters, like we are using PV plant. So during the day it will work through PV, and if it is like day down, means when the PV is not able to generate, so in that case it can extract the energy from the this energy storage part and can give it to the grid, or can take energy from the grid. So all these signals, how to manage the things when our battery is draining, how to communicate, how this will come to know that it should be connected to the grid, and grid should supply the battery. And when it is battery is already we are having the sufficient supply in our battery, so it should be connected to the PV, or it should supply, or either if I'm using like in this example to the EV. So like this how it can be used. So for this purpose, this particular communication can be created by using the particular communication protocol, that is the CAN. Similarly, here we have used the Modbus. So there also we are using that when the PV plant has to be, the different signals we are fed, that when it has to be supplied through the grid, when it has to give energy to the resident, means varying load or the constant load, whatever the load we have connected, and how it is getting the supply. So it is the purpose of the communication protocol, that how do we communicate and how we can inculcate. So that is the process I have shown you, that inside the user interface it is easy to inculcate when you are using the generic components. And when you are not using the generic components, inside the switching components, how you can use. So this is using the switching component. Here I have designed this Modbus, but here what is happening, that I need to perform some sort of a coding part inside the model initialization. That is we have done. I hope this part is clear regarding the communication protocol. How do we involve? And regarding this CAN bus loopback, this video is also present in your communication protocol, that is on Hill Academy. I hope am I audible?
Yes, you're audible, ma'am. You're audible.
Okay. So as we all are working on advanced scenarios, so that becomes important to understand these concepts regarding the communication protocol. Rest of the communication protocol, like IEC 61850, you have to be connected through proper Ethernet or something, and then it is going to work. I'm not going to discuss all of these, but the two commons which we are using nowadays industry, where we had the practical experience personally also. So that point we have discussed in front of you all to share our experience with you. Nothing else. Now regarding this Modbus communication protocol, uh, so here in this Modbus communication protocol, here what I'm going to do. So when I will unlink this component here. So inside this is the Modbus part. Now when I am talking for this Modbus part, I just click on this and go to the help icon. So there you will get about some coding paths, which is very important to be understood regarding the versions, about the coil index, about the coil discrete register, discrete input registers, holding registers, what is the size. So all these points are given here regarding this point, that what we can do, where we can write the codes, how can we read the codes. So what is the purpose of holding register, what is the purpose of coil register, all these details are mentioned here. And there are two versions we are using, that is the version register mapping version 1. So this is a kind of register mapping version 1. So here you can find, like if I'm addressing the coil input address, so if it is a 16-bit, so we can use only one single units like 0, 1, 2, 3, and 4. And when we are working for this 32 bits, so we will be using like 00 means two addresses we will take together. This is the example of 16 bit. I'll show you in my example. So for integer part, we use I. For unsigned integer, we are using the symbol U. And for the float purpose, we are using F. So here you can see the example. For 16 bit, we are using 0, 1, 2i. These are the address input registers, address location where we are specifying the address, and at that particular address, the things will be ported out. So this is the part. Then third address location is for the unsigned integer. Then fourth one is for the integer like this. For 32 bit, we are taking two at a time, two consecutive numbers or two consecutive addresses, I should say. That addresses I'm taking at one part. That is inside the bracket 0, 1 and another 2, 3, then 4F like this we are taking. For 64 bits, we are taking four consecutive address locations like this. Okay. And here there are various lengths. Regarding various lengths, we are having means involving a 32 bit, then 16 bit, then 16 bit, then here again 64 bit we get, means using different address location, that also you can use it. These are the some things where you can understand according to the computer science departments, and data has also been given on the Google. So there you can find out what were the series. So currently we are using the extended series. We are having this 0 to 6535 series, the address value series which we are using in Typhoon HIL. We are using this. There are some older locations also like 0 to 4004 series up till there was there like this. So that is there. Now this is the example of the register mapping version. So how could we map this register mapping? So that is the register mapping we are having. And this one is the register mapping version 2. Here we need to define the address 0, IO type, input, and with the value specification, then the SCADA and the initial value like that. And here just directly we are giving the address location. So let's see in my model how I have used the communication protocol here. So inside this communication protocol, so inside this you can find so this is I have used the register mapping one only, directly use the address location, not providing, not writing the scripts like address and like that. And in SCADA, we have also used like that. Two codings we have done, one in the schematic and another one is done in the SCADA part. So when I'll close the Typhoon test ID, there I'll show you the SCADA part. So here you can find like coil input registers. So for coil input registers, these value has been provided through this constant input which we have provided. Okay. And for the register input, these are the signal selections. Inside this signal selection, that which will be the address for F, P, Q, S and power factor. So these are the, for these we have assigned the address locations. So here you can find the address locations. Here we have assigned, like suppose this is for a register input. So these are the input register addresses, like suppose 0 for the state of the motor on and off. Then for the mode 1, then this is representing the frequency. Then this is representing your voltage. Then your reactive means true power P, and then your Q. That is the Q about the Q. So for this input registers, these are the input values which we are giving, and this is the address location. See, this is the address location. As the value is in 16-bit only, so we have provided the address location 2000. Then 1, that is the on and off state, that is, it can be either it will be 0 or 1. So again 16-bit address location 2001. Now for 60.0, this is a kind of a float. And for this float, we need to provide the 32-bit. So for 32-bit, use this consecutive address location 2002, 2003 like this. And for this voltage purpose also, we are using the 32-bit register because the integers are in float. Similarly, for the reactive power, and this one is for the active power and this one is for the reactive power. So these are the input addresses which we have given, and inside the Modbus we have given the address locations. Through this address location, these are the output address location where it will be getting the output address, and the same thing which we have designed in our SCADA portion also, because there also we have to define that what are the things which we are taking it out. Similarly for the input register addresses, so these are the input register addresses. So this is the register input which we are getting here from here. So these are the battery battery outputs, which whatever is the battery output, that is we are giving to the register input. Here you can see, and this is again an input which we are getting from this charging station. So this is how we inculcated this communication protocol inside this using the switching components. So you have seen two sort of things inside, means using the generic how you can inculcate, and if you are using the switching component, that how you can inculcate. Similarly, you can inculcate this particular Modbus to this PV inverter plant also. How can you do this? I just show you inside the mask. So like here it is inputs and outputs we are giving. So here we can use the Modbus communication protocol, and similarly as we design for this ESS, similarly we can design for the inverter part. In this model, it is just for showing about the purpose of the communication protocol and using electric vehicle as a DER source. So this is a very simple electric vehicle. I haven't used any sort of proper control option is not used. It's just like a very simple, if I will use a proper control option, so that would be much more better. The results would be as per expected. But the purpose of showing that this is the way which we can implement. Now inside this residential load is very similar as you have designed, you must have seen in this electric vehicle, vehicle to grid and grid to vehicle. So this is the grid and this one is the residential load, which we have designed the same way it is done. So this is about the communication protocol. Now what comes, you have done the innovations or the designing part in that purpose. So what happens? The things needs to be tested. So when the things come into the picture, when the things needs to be tested. So this is the test report of electrical vehicle, vehicle to grid and grid to vehicle. That is in case of blackouts, that means supply can be taken from the vehicle inside the house. And in case of the if it is not blackout, it could be connected, it can get supply from the grid to the vehicle, and supply can flow from vehicle to grid. Both the cases it can be done. So for that model which you have seen in the morning, that run means in the real-time simulation, and this is the same model I think which we have gone through. So the test which I'm showing, this is for this particular model I'm showing here. So here for different speeds they have tested some things. So here what is they have done, first they have imported the libraries, the particular library which we require inside the Typhoon HIL API, and you need not to worry about this that you have to learn the course or something. Go to the documentation hub, and when you will inside the API documentation, HIL API, schematic API, SCADA API, or even if I open the Typhoon test API, so here that several components are given, how to get the results, what the functions you have to use, that you can directly use when you want to give some analysis for the packages, for the results or the expectation or some values. So for that purpose, all these codes are given in the document. Only you have to write, and as per your requirement, you can get your results. You can test here. So this Typhoon test ID, the purpose of using the Typhoon test ID, I'll just show you. That is made for the certification part. That is for the pre-certified things, we are requiring these parts. Okay. Just maximize it. So this is the test report for the electric vehicle. So here you can see two colors are here. One is in orange and another one is in green. That means out of the 5 test cases. So what are the test cases? Let's see here. So the first part which we did, that we load the model to the this window. Loading the model means the prepared schematic is compiled, and only compiled, not compile and load model to the SCADA. And the file location will be same. The SCADA file, the schematic file, and your this test ID file, that will be test script which you have written, that would be in the same location for the easiness of tracing the path, because somewhere we feel that path is not easy to trace. So this is the file location where they have quoted. So their file location they have provided according to their setup, where this electric vehicle file is loaded. So that is the model file path, and then the model is compiled. Then how to add the fixture. So inside the structure they have added the fixture. When you will click on this component, you can add the fixture like this. Okay. So inside the added fixture, they have used the scope as module, where they are checking the condition for hardware settings. So hardware settings means for that purpose, they are using the Python script try and exit. Using these codes, try will check what is the hardware setting, and if it finds that hardware setting is present, so it will make the VHIL devices true false, and it will not stop there. Then another command using the exception. Exception, what except does? Except does is that it will again check whatever, even if it is false, then again it will come to some other conclusion and it will report the message, whether it is present or not. So here you can find that if it will try will show that virtual HIL device is false, and exception will even if it is false, then it will again retry the results and it will check that yes, keeping it as true, that even if we are not connected with hardware settings, so it should run at virtual HIL device. Otherwise, currently I am running on virtual mode, so you can understand that how this test code is done. So it is done for both the condition. If I am not connected to the HIL device, so that's true. So that is true. That means at that part of time, my HIL device is active. Virtual HIL device is active. Okay, virtually I'm active. And when I'm running test on the real time, so in that case, my virtual HIL device will be as false. So for that purpose, this two command has been used here. You can load the model. I'll just show you. I'll just write a small script for you all for inside the Typhoon test ID after making you understand these. Very simple, so that you can understand that writing scripts in Typhoon test ID is not compulsory that you should learn, but only you must have only a sort of a basic knowledge. Okay, so this they have loaded the value. Now for this SCADA input they are checking, like for the vehicle speed or the means throttle we are like whatever the fuel value is at 0 or whatever the throttle we are provided. So it is setting up the throttle value as do we select through API in our SCADA. The same process we are selecting here in our this part in our Typhoon test ID, the same procedure. Okay, and then it is checking for the start motor condition. It is given that initially it will be 0. It will be 0. It means it will be at the stop state. My motor is not started. As you have observed in the morning session in the SCADA part, you have stopped. First it was a stop. Then you made it to the start, making the initial making the value to the 1 when you are clicking on that icon. But initially it was at 0 condition, that is at stop position. Then for the acceleration, they are checking, like suppose they are providing throttle like 30, 50, 80 and 100. These are the different points they have given. Okay, so for that case of different points, if you are giving, so in that case, what is the acceleration? What is the maximum speed? So for different maximum speed, keeping the wheel diameter and the gear ratio. Now, what is the gear ratio and other concepts? So gear ratio, I can only say that in motorcycle or in bicycle, you have seen um, the first wheel and the second wheel. I'll just show you the picture, then it will be things will be much more clear. if it is present in my system, then only I'll be able to show you up. I just check whether that file is present with me or not. So I'm so sorry that file is not present with me regarding the Hill basics. It was the file. Okay. It's in my old system and it's not working. Otherwise, I would have shown you that particular point. All the basics of EV that is there, how to calculate the battery and other parameters are also there. So that point has been done. So okay, no worries. Only you can understand about the gear ratio means for the front wheel and the back wheel, where we are calculating the ratio. So that is a kind of a gear ratio, and also that we have implemented as a mechanical transmission ratio in signal processing block. You have used some particular values inside the gain block when you were putting. So that is mechanical transmission ratio or the gear ratio, you can say that is the same thing. So here inside this electric vehicle, now what they have done in the next step, they have started the motor and capturing the data. Now the duration they have given that for particular duration that it will capture the data for this condition it is given like 100. So for this they are capturing the data, rate it is given, signal, what are the signals they want to watch, like electric vehicle or this mechanical electric vehicle or electric vehicle mechanical speed. So all these are the signals. Now how you are getting this data, I'll just let you know. Inside this API wizard, simply like if it is Typhoon test capture, I'm coming to this library, selecting the library, and what they have given the, okay, whatever be the library, I just show you. Suppose get the capture results. So inside the capture results, you can find something. I'll do it on other field, otherwise it will get me the error. So, okay, so here like this you can get through the data. Suppose for the SCADA they are looking for the results. So like that I'll show you on different wind. So these are the tests they have done for different acceleration speed, and this is the report which they have generated. So the reports which are generated, you can see here you have for test electric vehicle. This is the out of 5 tests, 2 have passed and 3 have failed. So what is the cause of the fail? Can we see here? So the cause of the fail, that here it responses under means acceleration for different throttle values and throttle which is given 100. So this is the setup they have given, the load parameters. You can find all the details, you can find about the model property value, about the compile load model and other things. Regarding the SCADA input value, can you find they have enabled it to 1, that which we are doing through the SCADA. Then for the throttle value they have provided 100. Then capture results, they have tried this, given the different offset absolute value and different offset means relative value, keeping it as. Then for capturing the results, they have provided some sort of a delay using the wait command. So the wait command, that is for 1 minute, 1 second, we give the wait command in order to do. So in this speed, 0 to 100 kilometer hour time, that is time is 4.026, checking all the final speeds up to the limit of 230 kilometer per hour. So this is they are showing us. Now here you can see the torque into speed characteristic, torque speed characteristic. You can find the power characteristic which you have already seen in the SCADA in the morning. Then similar other test for acceleration. This one was for 100, which I'm showing you right now. This is for the acceleration for 30 when they have given the throttle for the 30. And then another test for the 50 also it will, but it passed for the test acceleration 80. So for 80 we will check that what is the thing. So the time is here and they have checked the speed for all these parameters. Their torque region is this. Now let's check the torque characteristic as well as with the power characteristic. So for this purpose, the test has been passed, and why it is passed? So it is the as means the written it is here that they have asserted to some other values, but the limit for the speed and constant torque region and other tests are expected to fail, but at throttle value 80 the results were came as expected. So this is the reason why it passed. So similarly, these tests are performed. You can give your test for other values similarly here, as they have provided the test for the different throttle values or the acceleration values. They have provided the test. Similarly, we can also do. Now, with respect to microgrid and grid codes, we have also some sort of a test which you can see. So this one is another test. I have not generated the report for this because again it would take some time. So, but you can generate the report. So here I'll just show you that as per international standards, the grid codes are also LVRT and your RAM test, other test you can perform here. So in this you can find this is the test where we can perform. This is the test regarding the test voltage right through. Using the parameterization, we can give this test. We can define def is used for the defining the test, and when the reasons, what are the reasons, like from steady state to the nominal voltage value, they have given the voltage right through three conditions: steady state, reason, and then nominal voltage, providing the trip duration, providing your operating state time, means what will be the steady state operating point, then pre-fault power, whatever. So these tests you can perform. So this is voltage right through, one test you can find. Then another test for the MPPT you can find here. So for MPPT, they means regarding the output power should follow the MP means maximum power point power. So for that purpose the test has been provided, and then test is provided for the RAM test, which is provided that the particular time is given that it should take or like 1 second or something, or finish it straight to the maximum power point. So these are the tests which are given in NPC PV inverter. So the test is also given and the schematic is also provided here. Now suppose for this part, how to write the test. I'll just give you a very small idea. Making a big model, it's of no use. So I just give you a small idea. I know participants are least interested regarding this part, but when you are moving ahead with the advanced things, somewhere this basic knowledge may lead you some other innovative part. So here I'm just taking only a signal processing. From signal processing, I'm taking one source like a SCADA input. And this is SCADA input. I'm not changing any specification. I'm just taking it randomly. And then I'm taking a probe. Normal probe we can take. So this is a probe I have taken, and just I have connected this. Now I'll save this model because it is compulsory to save somewhere. So I'm saving it in NIT Delhi, making another folder. So this is a folder, naming it as models. Just naming it as model. Open this. Inside this saving NIT Delhi. NIT Delhi saved. This model I have saved. Now we will I cannot compile. I can only compile this. I cannot load model to the SCADA as this is even if I'll click, you can see that this action cannot be taken because already our Typhoon script editor or Typhoon test editor something is open. Yes, that's true because we are still in this Typhoon test ID. I'm just compiling this model. So inside this model, come back to the Typhoon test ID, closing this file. EV file is still open. I'll just open new file, and this new file I'll save it script as means to the location where I have already saved that particular model file inside your NIT Delhi folder. Inside the models. So here I am saving NITD. So this is my file. I'll just save it. So it is asking, do you want to change the directory? Yes, of course, because my current directory is following the path where our Typhoon example is there. So here now I am changing the directory, and as I change the directory, so it will come to this part and selecting the folder. So here I have selected the folder with this NIT Delhi. This is my path. Okay. Now, first and foremost part which I am going to give, that is I am going to add a test. So for adding a test, I'll just write test because we are only for the kind of purpose that writing the parameters only that using. So okay, test 1 I'm using. Now as I wrote the thing for the test, so ultimately it what happened? It took the library import PyTest because we are using PyTest for the test and automation part. So it is taking. Now it is already giving the instruction that what you can do, that we can means add my code here. I can add my code here. Now for adding the code, what I'm going to do, I'm going to API wizard and going to HIL API. So when I'm going to HIL API, so it will ask enter alias for the selected module with the HIL. Yes, of course, going with that. Coming to this, I'm just trying to get that first and purpose was that load model. See, I have not prepared the SCADA for it, so I'm not sure whether the results will run or not. So I'm just trying to show you the contents. So I'm just loading the model here. So for loading the model part, here you have to choose the file and you can load the model. So inside the model, I'm using this. You have to take the CPD file. You can open it. So it will now take a compile. Then inside the file control, take a file picker and you can browse that particular file, this file, and you can open it and press it open. Now here I am going to add a comment where it is written, I will virtual HIL device, I'm making it true because I'm not connected to any hardware. So it is I'm making it true and simply insert the function. The function has been inserted here. Okay. Now line by line, I can check the things. I just run the test and just check. Right now, it will not show. Means if test is not available, it will show it's not available because we have not working means for given many tests. So it is showing only one test. I can show this and this test is this. What it is showing, that file cannot be loaded. The file may be corrupted or please recompile the file. Why it is showing? Because I have not prepared any SCADA for it. I just only compiled it. Its SCADA file is missing in my folder. where the navigating folder where I posted this part for this particular this SCADA part, and I'm not having that particular file. So that's why it is showing that my file is corrupted or it is not loaded, because it is only compiled, it has been not loaded, its results are not where on SCADA the settings has not been done. So from the path it is not getting where it is going to show the result on the display or something. So it is giving the test that it is not recompiled. I hope everybody got the thing clear, the purpose of test and automation. I just simply wrote the test only for loading the model, that it should load the model on SCADA, and it is not loading the model on SCADA. Reason is that its file is missing and our test is showing that it is failed. I think this part is clear. I just wrote a small code for you all that this is how you can insert the function. Similarly, now regarding the SCADA, I'll just write, I know that whether these things are not going to get it. Now suppose if I want to start the simulation for like if you have present your this part SCADA file, it is present. You have to simply click and this code will pass, and this is HIL start simulation. Now for the SCADA input setting, suppose for schematic API, I will get into the model, yes, and inside the model, I want to have the get SCADA input value. Yes, set SCADA input value. So this is it is coming. So I will choose the file. The file again which I'm going to choose is that the particular that file only I'm choosing which I have used. So it will open it. It will compile. Then inside this SCADA inputs, I have the option that is SCADA input 1. This is the SCADA input 1 we are having on our schematic. See, SCADA input 1. So that is showing to me because it is present here and it is showing. So this SCADA input, and for this particular SCADA input, what value I would like to, initially I want to keep it as 0 or 1. I can put the condition. Suppose for the first condition I am putting it 0. And similarly for the second condition, as like we do on SCADA, to make it enable, I am choosing it 1. And again insert the function. Suppose if I want to read the signal for the probe which I have taken. So either I can have the option with the schematic editor, if we have the option for the read analog signal, or we can have the signals from this particular Typhoon test signal that will. So this is signal. So inside this signal, we will check. We can give some signal like when we want to give some value like reading the signal or something that we can give. For giving the value, suppose I want that particular signal for that particular point, it should be like this. Means setting a point like the particular input which I am giving here 1 and it is connected to the probe. So if I want to vary it between -10, 0 or 10, so I can simply write like giving the points, like how would I give the points? I just show you. Adding a fixture. So inside this fixture, I'm adding setup. The fixture setup and function, I'm taking it as module. So here I have taken the module and my function is setup. So here I can load this particular value, my setup point, or I can here give some value like assert means inside this I can like setting points. So this is how you can means in the scope you can inside the module you can rewrite these files. That part you can do here inside this, that you can do. Now suppose if I want the same thing to be happen, that is I need to parameterize some component. So I'll just copy this code and I will parameterize. Now how to parameterize these parts? Inside this, instead of fixture, I will write it like mark parameterize. Or here we have a table. If you are already having that table, so you can use the new Python parameter. If you are having that parameters that you can do, otherwise we can do like this in this manner also. Mark parameterize. And I'm giving here inside the set points. So when I will give the set points, so like suppose I give the set points from minus to positive. Microgrid we use for giving these points, no? For setting the points for reactive power or the active powers like that. So this is the way we can provide. So here you can provide the set points. And in this set points, I'm writing an array inside the bracket that is from minus 10, 0 and 10. This is my set points. Now it should navigate in between these points, means in these points I need to have, and this is my parameterization command. So here when I'm giving the points like here, so I will give a test regarding this. And what is the test? How would I give? So I am going to add a fixture here. Or you can directly, instead of adding a fixture, I'm just copying this div setup. This is the same command we are going to get. And here I'm naming it as different because that was the setup. Setup means it should load the model and compile the model. And another one, that is it should test in between those points. So here the where it should be there, like my setup points inside the setup and with this setup point. So this is my setup. Ultimately it will come and between these points, set underscore point, it is coming there. Here what we will write the thing, like suppose here I can give the command that here the simulation is starting. Here okay, it is already, now I need to stop the simulation here. So after yielding the result, I am stopping the simulation. So for writing the stop simulation, I need to just give the command, go to the API wizard. Inside this HIL API, or already the API is there. So inside this HIL API, when you will find this stop simulation command, so that command you will get. And also for the analog signal read, if we want to take, so that is also there. Read analog signal, we will be using the command. So for stop simulation, so I will write this command. So here the simulation will stop. Now again here I'm going to give the points. And what is the point? Like here my value was 0. Now again I'll copy this SCADA input value, and here I'm going to give the value equals to my setup points. These points, the point which I have defined, minus 10 to this set underscore points. So with these points, it will, I will go the test. We are performing the test for this. So -10, 0. And then we will how to read the signal. So we will read the signal. So here we will read the analog signal. So the option it is here, read analog signal, and I'll choose the signal from here. So here my probe 1 is connected, you can find. And okay. Now here I am going to insert my code. So this will read the value. Now after reading the value, I want that it should assert the particular read. So assert you can give either through Typhoon signal report. Otherwise, without using this, you can simply use this command. So what you can do, you can define this is it has some value. You can give some value like read value or RV, whatever the short form you can give it. So this is the read value. So I want that this read value could be multiplied, or it should be equal to set point. What is my set point? Set point into 10. I just run the test. Now, definitely, already I have not loaded the model, but for this test, definitely the condition which I have given, it is going to be false if I will load the SCADA part. So in that case, so see, no results is there because no test has been included for this, as the result is not posted on the SCADA, but here it will give the result wrong only. Reason is that in our schematic, you can see this is SCADA input, suppose it is 1. So output we are going to give it as 1. Now the set point which we have given from -10, 0 or 10, whatever the point we have given, if it is on the command window which I have given that it should be multiplied with this value 10. So that means in SCADA we should include a gain block between this SCADA and probe and giving it a value 10. Then that particular test will prove to be correct. Otherwise it will prove to be wrong. Reason that it has not given the test setup for this, because I am not having this file in the SCADA. So I hope a little bit knowledge means with this short description, you must have understood that how we can use this Typhoon test ID inside our platform. A complete test results I have shown using the electric vehicle, and a short script programming type that how to use it. That also we have seen using the script, that how can we write the script inside the test ID. Is it clear to all of you? Means in this regard, if anybody wants to ask regarding the Typhoon test ID, you can ask. Otherwise, I need to close because another model is waiting in the schematic regarding this one, because I need to show you the purpose of how we can use communication protocol. And in virtual mode, my every result will work, but this communication protocol is not going to work. But as it will be connected through real time, Dr. Salam will be connecting the same model. Then you can see that particular result will be coming in the SCADA, means on that particular block. So with Typhoon test ID, any issues regarding the communication protocol which we discussed right now, as for the purpose of EV as well as for the in case of microgrid? Because we as an researcher or academic, you all know best the theoretical knowledge, because you are much more superior in that case. But what we were having the experience regarding the practical experience, or the things which we are using in industry or some other industries are opting, those who are working in these fields. So those experience we shared in front of you. Faculty members and research scholars, any questions regarding this Typhoon test ID? Any confusion? In fact, whenever you will select any signal, so inside for each particular signal, it will show that how it will read the signal, the argument which it is given. So what is there, it will show. And also on the PDF page, I have shown you that what commands and how to use it. So suppose here it was the command. So the command which we have used from here, assert we have used, we are analyzing it, means multiplying the result with the particular 10 points and waiting that whether the result is coming or not. We can we use the capture point where we read the analog signal, means one read analog signal is read from there. Then we have other different packages you can find here for test ranges that you can use. I've used very small things that could be understood as per the requirement. And each and every point is present in our, I'm not telling anything outside from this software. Each and everything is present regarding the HIL API. What are the commands regarding the schematic API? SCADA API, each and everything it is present. Even for the Modbus API, it is also present. If you would like to use the commands in that case, like suppose if I use this Modbus, so here this command we have used, try and accept, we have used in our SCADA. So this is present here also about the Modbus communication protocol. Um, Guys, please tell us so that I can proceed further with the other part. Should I close the Typhoon test ID if there are no queries? Because once I close this, I'll take time because SCADA and this test ID could not be open at the same moment. Any reply from the participant end? I think after having lunch, you're all feeling sleepy and then again the boring lecture, right? If you are posting on chat box, I won't be able to see the chat box because
లొల్లి అయింది ఆమె శృతి చెప్తుంది అప్పటి నుంచి ఆమె ఏం చెప్తుందో ఆమె కూడా తెలియదు అలా మధ్యలో ఉంటుంది
yeah, somebody was saying something, I was unable to hear it. Participants from NIT Delhi, those who are participating, can I get the replies from them from their side? I hope I am audible. Co-ops team, could you please tell
Yes,
me?
yes, you are completely audible. Yes, but no participant is
So,
responding. I don't know why.
I think if participants are not responding, so I think we should wind up here
Yeah, yeah, yeah. But
because
might be possible we are not telling their area of interest in which they are working for. This might be reason. And someone is saying, yes, please continue, ma'am. Mr. Balram Kumar.
because I cannot see the chat box, you can see now I'm not getting the chat
Yeah, yeah,
option.
yeah, yeah, yeah. Mr. Balram Kumar is saying, please continue, ma'am. And Shiva Kumar is yes. I don't know what on what context he is saying yes.
In
If you can unmute yourself, then you can unmute and then speak. It would be much more interactive.
Yes, Mr.
I
Shiva
think
Kumar.
because
we said audible, so I have said it.
Okay, okay. Sir, are you getting what ma'am has ma'am was telling? Are you getting the test ID and all?
Yeah, sir. Little
Okay,
bit.
okay, okay, okay. Fine, no problem. Thank you, sir. Thank you.
because the material, whatever I have told you that you are going to use in your research as well as in your future application, whether you are working in the field of microgrid or EV, without test and automation part, your innovation is somewhat incomplete. Because in Typhoon has provided this kind of Typhoon test ID. This is a pre-certification tool as per international standards. Like for microgrid, if we talk BDW, then we are for different ride-through test where we are using UL1741 test. So different tests we are using for this MPPT. We are using the SORIF. So these are the international test standards. When you have this is a kind of a pre-certified tool. If things are tested here, so 99% it is expected to pass. Anyways, I just close this Typhoon test ID part. Coming back to the SCADA part. So this was the model. I'm just compiling and loading back to this SCADA. Only to show you the communication protocol part. So by the time when it is building the model, loading the model to the SCADA, at that time it is interpreting line by line and it is trying to build up the model and hence loading. So this is the SCADA file. I'm running the simulation. I need to define the PV source file. So I'm loading the PV source file. So I'm using the different PV file, which is present in microgrid example in PV plant. So this is PV at the rate 250 kilowatt I'm using, giving it a temperature like 1000. And then it is 25. I should give it as making the contactors closed. So this is the battery inverter, the full SCADA part you will see when it will be run from the office, because that full file is in my older system, and in this system it is not present. So here you can just see that this SCADA Modbus client which we have generated here. So in this SCADA Modbus client, like how we have written the code. So here for each widget which we have placed, that is the checkbox combo. There we have given this like on and off mode. So for on and off mode, the output register value that is assigned to location 0, which we have already given inside this model initialization part. And here you can see this is the holding register output, that is 0. So that is means at 0 location. So this one is the address location 0, 1, 2, 3. This is how we name the address location. And similarly, the same thing we have designed in this SCADA part. And this giving the address location at 0. So here it will try and then accept. It will check by means it will do the cyclic redundancy check, and after that accept will do even if it is not as per the conditions. So it will show that Modbus server is not connected, and as we are seeing that our Modbus server is not connected. I'm giving the SCADA inputs is here enabled to as 1, so that we could get some results for the SCADA part. Load we can give. So batteries reference, giving it as enable 1. So PV inverter, making it on by enabling it, because widgets I have not put there. So see, it is now on. But my MPPT is not tracing so good, because I told you that proper algorithm have not been used here, and EV is also showing you this battery is draining out as it is in the grid forming, and as I'll switch to the grid following mode, so it will show some results. This synchronization part. So when it will be connected to real time, you will get the results much more better, because this is again the battery inverter inputs are again dependent on this SCADA parts. So here you can find this address value for the inverter. This is for the mode. So for mode, the address location is 1. Then for frequency, we are having the address location 2. How it is, you can see inside in this. Here we have initialize this part. So this is 0, as counting starts from 0, 0, address location 1, address location 2. So frequency is at address location 2. Similarly, here we in the as the coding part is done in the schematic, similar coding part has been done here in this part. So here you can see that the EV battery is draining and MPPT is not boosting too much. Means maximum power point tracking is not. It was just an example model only to show about the communication protocol. Then inside this SCADA part also we have initialized the script where we have written this part. Battery server address 192. This is given port 502. In schematic also here, when I'll just show you here the configure part, we can see the configuration part, port number it is given, IP address it is given, net mask it is given. And inside this mask, when you will see, so here I have written Modbus configuration configured to battery. What I have assigned here, the same in the model initialization. Okay. And source I have taken to dictionary. You have multiple option either to the dialog box or the SCADA, but I've taken to the dictionary. So my dictionary is provided here. So this is my dictionary, config battery and dictionary. So this is the part. In the SCADA part we have given and used this Modbus API document we have used. Here the code is given how to write the same code we have used in the SCADA panel. So that is acting as in client and slave server setup you can see here. So when I'm running on virtual mode, you can see that this Modbus is not working, but when it will run on the real time, you will see that this communication is going on. So this is a client for us. And on a schematic, what we have designed, that is a slave for us. Means server, it is working as a server. So that was all regarding this part. In this part, if you would like to ask something, so you can have, we are ready to address it. Regarding control with Modbus, I think Salim sir, you are connected with real time.
Yeah, I'm connected with real time, but here I'm facing a problem. I think my file has got corrupted because the it is not getting controlled with Modbus. I'm still trying. So because some problem is occurring in this
Okay, no
file.
issue, no issue, no issue. Even if you are not able to get this file, what you can do, uh, in our example model, there is one file, no?
Yeah, which one? Yeah, yeah. I can show that one. Just
That one where we have used the Modbus communication protocol. I just show you the file location once again.
yeah, yeah. I also have
You
that.
can use that only for showing. We need to show the Modbus communication protocol as participants were interested in this microgrid portion. So I showed them the smart grid, how we can work on that part. So that I have, that we have shown. Inside this communication protocol, we have this model, no, Modbus client and server setup.
Yes, yes.
That model you can run. I just simulate here also on the virtual. They can see with me that is SCADA is not working.
Yeah, yeah. Yeah, wait. बंद करे अपन इसमें देखो अपना कौन सा है ये वाला बंद कर दो मेरा स्कीमेटिक चलो मेरा स्कीमेटिक बंद करो इसका बंद करो माइक बंद करो
So here I am running it, and you will find that this is about only the battery energy storage system. Now here this control is not working. This Modbus control with Modbus, it is not working. You can see that as we are running on virtual mode because it is not able to communicate. So using 402 HIL device, they will be connecting through Ethernet. So they will let you know. You can see that this particular widget will be working in that real-time simulation. So should I close this, Dr. Salim, if you're ready?
just give me a minute madam I'm just setting up okay just give me a minute yeah.
Okay, no issue. So meanwhile, we are ready to address the questions of the participants. There are many more things that we can explore. Even you can suggest us also that what else we can have is an improvement inside the software, means as per your expectations, or if some researchers are working in some other field. So that could be a plus point for us.
Ma'am, actually for that I need to connect the Ethernet, so I'm just take much more time. So I need to have the Ethernet connection for the same, now. So I have connected with the USB cable. Hello.
Yeah, Salim sir. Yeah, Salim sir. Okay,
Yeah, yeah.
fine. Participant and we are ready to hear the questions. If you are not going to respond, then we are not going to show the magic using the that hill box. I'm just talking like a kiddish. All you all are just means so much senior in all the respects.
Ma'am, is that test ID lesson parts are available in Hill Academy?
In Hell Academy, that is test and automation course you have to take. Inside that, they have discussed about from how to write the course, each and everything that is present there.
Okay, ma'am.
The title is test and automation. It will be from this title there. And for EV, we conduct ECU test, and that ECU test, that platform is a bit different. There also we use the Pi test. And with Typhoon, we can also use the PyCharm also, if somebody is interested in coding part. So for them, I'm telling. Anything else? Nobody is working on communication protocol. Means nobody is using that communication part in your microgrid part or EV part in any of these two parts.
No, ma'am.
Okay. So that's why the response regarding this session was quite less. Salim sir, if you are facing any issue, we can skip then, because nobody is working in the field of communication,
Yeah,
means
yeah.
nobody
Just
is
just
using
uh,
communication
give me
protocol.
give me a minute. Just I'm just setting up. Yeah.
Okay. So could I get the feedbacks if nobody has the question to ask? So could I get the feedback that during these 5 days, how you all felt? Means were the sessions really worthful for you, or it was just waste of time?
No, ma'am, not waste of time. Yes, we did learn many things, and hopefully, I've started my PhD and will try to incorporate some of the ideas in my project as well. So it was informative.
Okay, thank you. If anybody is working on EV, they could post their give their response regarding the morning session, or the since 2 days we ran up the session for EV. Till then, Salim sir is connecting on a real time that particular communication protocol. Okay. I feel that nobody is using communication protocol in your advanced field. Inside microgrid, if somebody is working, so could somebody help that during the microgrid demonstration which was given by Ansari sir, how did you feel like that? Means was that worthful? Because it was very long model, and modeling from schematic to SCADA, it would take at least, it is the personal experience to follow up with the participants, along with the participant. We need at least 12 to 16 hours. 16 hours means total 16 hours for creating one microgrid model, either using the switching or the generic, because controller part is difficult. So for designing the controller part, this time is required. So that's why we only demonstrated that. But how to use the signal processing toolbox, we ran the, means we modeled that particular example of EV using the signal processing toolbox. Again, with the EV models, those are also too long. We require at least 16 to 18 hours each. So in these 5-day session, we can only give you the highlight. Even the Typhoon test ID part, which we covered right now, that is also again something. Salim sir, are you there?
I was just building the Ethernet connection and just run the schematic model. Let me just test the results of this model. I have run it right now. Then I
Oh,
will just demonstrate in 5 minutes. Yeah,
okay, fine.
yeah. Hope my screen is visible.
Yes, it is visible. Thank
Yeah,
you
yeah,
so much.
yeah. Welcome, ma'am. Just
So the communication part, which you have seen that virtually it was not showing the result on SCADA. Now you will see on while connecting with the real time mode, it will work. And after this, you could show the participants that in the morning session, they have seen that you were connected through USB. Right now, you are connected with Ethernet.
yeah, yeah, yeah. Just
Yes.
start as a controller. Mode as a control.
I think there is some issue with the connection of the device. They must be connecting back.
Oh, we have done the Ethernet connection. Let me show you the devices connected with Ethernet right now. Just let me show. Yeah,
Mhm.
here you can see in the device manager. We are now on the Ethernet. Actually, SCADA is running. So we have. Let me show you once again.
No
Uh,
issue. You can run the SCADA. You can show the results. Then show them this connection.
okay.
Yes. Let them see that the Modbus is working, which it was not working there. Your screen gone.
Yeah, yeah, just presenting. Okay.
Check with the contactor settings. It is closed or not.
Yeah, yeah, yeah. Let me check it. The IP
Yeah,
of
check
this.
your device
Yeah,
whether
yeah.
it's connected or not.
Yeah, The device is connected, but actually I need to change this in schematic this ID. Just wait. I need to change it.
On a schematic, you need to change, I think.
Yeah, yeah,
But last time means okay, must the settings must have changed. I can understand that.
yeah. Laptop 52, 42, 42. Yeah, just make it 40. 219. Okay, and in the schematic also.
Again, we have to then reload it.
Yes, yes.
Here they are changing the IP address. Yes, see, now the results are coming. Thank you so much, Salim sir. It was insane.
Yeah. You can see the inverter is getting on here, and it is controlling with the Modbus. Fine. Yeah, earlier it was not working. Am I audible, guys?
Yes, you are audible. Keep the screen for minutes while so
Yeah.
that others can also observe that on virtual this Modbus was not communicating now
But right
after
now
connecting
this,
with Ethernet.
yeah, first one is the SCADA command panel, and second with the SCADA Modbus client. When Khushbu ma'am has done this on her laptop, she was running on the virtual mode, and this was inoperative. This SCADA Modbus client was inoperative, and right now is completely working. And as you are able to see on your computer screens, and when I'm just unclicking it, and this is has gone. This LED has switched off, and when I just click it again, you can see this LED is again glowing. So this is completely controlling with the Modbus, and this is not in the case of the virtual hill. So this is one of the example of Modbus communication protocol which is available in Typhoon Hill library. So if you want to do more research on it, you can go and have a look on this. So this is what is from my side on communication protocol, and I want ma'am has already just told a lot on this communication protocol and all. Okay, is that okay, guys? Khushbu ma'am, is this okay?
Yeah, this one is okay. Participants, are you? I hope it is visible to all of you.
Let me show the device is connected in the device manager with with let me switch close the SCADA. Then you can one can see, yes, it is connected with the
Ethernet.
Ethernet. Yeah, yeah. See, you can see earlier it was just coming in the interface like USB. Right now it is coming with Ethernet. So in the Typhoon Hill device, we are having the USB port as well as we are having the Ethernet port. So we have connected with the Ethernet this time. So there is a standard procedure for connecting the Ethernet cable with your Typhoon device. So it takes time. If you are more interested, then you can contact us personally. We can tell you that same procedure. Just simply we need to change in the configuration IDs of the IP internet protocols. So is this okay, Khushbu ma'am, from my side?
Yeah, thank you
Yeah.
for your this help
Yeah,
because
yeah. Thank you. So you're
help
welcome,
we
ma'am.
could only provide from the office because
Huh?
device is not available with me.
Yeah, yeah, yeah.
So we all have done from our end. If participant has to address some any question, because this was the most waited part which we were waiting regarding the communication protocol, means working through, means connecting through Ethernet. Typhoon test ID we completed. Regarding the test and automations part, we I just show you somebody asked that question also. So in the morning, I think Salim sir, are you giving me control?
No, no, I am not giving any control.
Okay. Then here I just show you the Hill Academy. You have these courses. Whatever I have told you today in the this Typhoon test ID and
Yeah,
communication protocol, that is definitely going to help you in qualifying these quizzes. I'm not logged in with Typhoon Hill. I need to log in with Typhoon Hill first.
I'm sorry, I didn't get you. What you were saying something like what control you're talking about? I was indulged in some work.
Means control means there was some request was coming from that wants to take up the control. So that's why.
No, I don't know. I have not initiated anything like
Okay,
that.
okay,
Okay.
no issue. Sometimes maybe wrong click.
Yes, yes, yes.
So this is about the specialized course. So regarding the communication protocol, you will find the number of things regarding test and automation. The person who asked. So inside this, you will find the number of tutorials. Video lectures are also there. Okay. So that is also there. You can find here. And from they have started from Python basics till Typhoon, and these are the quizzes which I was expecting that you would solve, and somebody would come in these 5 days, somebody would come with some of the certificates like Hill fundamental certificate or some other certificate, because 5 courses, 5 days, 5 quizzes were to be solved. So these are the courses for Hill fundamental, Hill power electronics, Hill for microgrid, test and automation, communication protocol. So these here you have to, and at every 15 days or every week, the questions will differ, because as they are proceeding, they are updating their these quizzes here also. So every day there is a new question list here. Then regarding the upcoming webinars, we are also conducting some webinar in our this Quads info system, that will be again topic wise, and you can see the Typhoon Hill webinar list for your reference. So here there are several webinars along with the videos regarding whatever the development they have done year wise, it is present. You can go through. Then if it is for you something interesting regarding like microgrid or the smart grid controller algorithm, see here it is the test part, means controller hardware in loop, pre-certification of inverter grid code complaints according to German BDEW, Italian, then UK. So these are the international standards which it is following as per Austrian Institute of International Technology. So there are several papers also where you can find they have used this UL 1741 SA, means all these international standards. So inside the published papers, you will find there are a number of papers using microgrid and electric vehicles. Now the trend is for BMS. So BMS testing
Excuse me,
part.
ma'am.
Yes,
I
somebody is
have a
there.
small question.
Yeah.
So, for communication protocol, can we use Python coding everything?
Yeah, I used Python only. I test.
Like, no, no. Like, we have to write. I am also using OpenDSS for using the communication protocol to
Mm-hmm.
interface both Python and OpenDSS. So, is it possible using only Python? The OpenDSS code will be interfacing with the Python actually for
Yeah,
my
the
project.
same code which we have done that was in the Python only.
But how to import the OpenDSS code in Python? Can you please help in that?
Sir, OpenDSS code in sir, here you can go accuse the one file is there.
Ma'am, your voice is echoing actually. You have a mute from side to device, I think. It's
Pardon?
it's getting revert to us.
I didn't get your voice.
Who, ma'am? What is it?
That's okay.
Oh, it is repeating. Mine also coming two times.
I think somebody mic is open. That's right.
Hello, I'm here. Uh,
So in your
I was
Typhoon,
trying.
in knowledge base,
in knowledge base when you were
all these questions
all
which you are
these
asking about,
questions which you are
to
asking about
get the file
to
through
get the file through
OpenDS or something,
OpenDS or
that is
something.
present
So
here.
that is present here.
And just if you
But the
find
problem
Just
here
if
is,
you
ma'am,
find any
from that part,
I was
from that part,
create a
you can
ticket
create a
instance.
ticket instance.
yeah, I got you that one. But I have raised ticket, and they say like we are helpless for now. You just work on Python coding, and you give us, and I will we can update you in Typhoon coding. Actually, the problem
Sorry,
was with me is in OpenDSS interfacing Python using Typhoon HIL Typhoon HIL. So for me, I have to introduce a fault for the 13 bus system. So it was very hard for me to find how to introduce fault for little bit of time using Typhoon HIL. It will be
introducing
taking
fault
like two.
where you
Introducing
want
fault
using the
where you
coding
want
part,
using
you
the
want the
coding
fault
part,
to
you
some
want the
other
fault to some
references.
other
Once again,
Means some
means some
I want to ask that some
yeah,
want to
other
ask that some
source
other source
you want,
you
or using
you want
coding
or
do
using
you want
coding
to insert
do
the
you
fault?
want to insert the fault.
I have to introduce the fault for few seconds, then it turn it off and go to again normal condition.
That you can do
That you can do
if you know
if
only
if you know only
that you can insert the fault
that you
for
can insert the fault for
insert.
insert.
I think
Ma'am,
that
your
was
voice
I
is
told
think
breaking.
that was told in
2 day session before
2 days session before
capturing the result for
capturing the
some
result
part
for
you can insert
some
the
part
fault
you can
short
insert the fault short
using
use
inserting the
using
inserting
inserting
the
the code the
Ma'am, your voice is breaking, ma'am.
is my voice is
Uh,
is my voice is
I'm just putting
I'm just putting
இது வந்துச்சுங்க ரெடி பண்ண
வந்துச்சுங்க.
I cannot see the screen, ma'am.
now.
No, now also I can't see anything.
And my voice is now
My voice is now at
Yeah,
yeah, that
yeah,
was
that was
I was
it
showing
was
you.
showing you.
yeah.
So
So
could you get
could you
that
get
from
that from
the test
in
suite
the
you can
test so
get
you
it
can get it
you can
or you
insert
can
the fault
insert the
without
form
using
with
the
Yeah,
the
I did it in this one. Then after we can check. Have to. Yeah.
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 Okay, we are using dynamic grid fault for here. I have taken just a normal fault grid fault.
Means all the
Means all the
is mentioned
is mentioned
also that is
also that is there
and for
and for
fault also
the also you can find
where you can
where
use
you can use
input
input
method or
method or
data
data.
Mm-hmm.
And any tools
any
to
tools
use,
to
you can
use, you
use
can
Apache
use
container
Apache
also.
container also.
So fault, I have to introduce fault at
Sir, you can
So
go
you
through
can
the
go through the
examples which
examples
is
which
present in
is
power
present in power
system.
system.
It is
It
present
is present
example, I
yeah,
think.
I'm
example, I
here.
think.
I'm here. I'm here. So how should we see what happens for me when I was introducing fault in the preview inverter? This one, it says you have only the execution rate is beyond the things. So we have using core coupling here. Okay.
So this
So
is not
this
a
is not
model.
a
This is
this
on
is
the same
on the same
side, just
side
drag.
just to drag.
What was the
What was the
facing your
facing the
execution rate, no?
execution rate, no?
So
So
inside the
inside the
modularization, you can
modularization, you can check
execution rate
execution rate.
Okay.
like here.
Like here.
Mm-hmm.
Or could you
Or could you
working
working
just explore
just
it
explore
more?
it more?
Uh, okay. I will email you regarding that one. Can I get your email or address so that I can make sure?
I cannot
I
recommend
cannot recommend
networks because
No,
I'm
because I'm
not
no, no,
getting
no, no,
that.
not like for
KP,
suggestions.
K for
K
Kushbu,
for
P for
Vishnu, E
football,
for football,
KP at the
Mm-hmm.
rate.
at the rate.
Voice is
Voice is
repeating.
repeating.
Mine also
Mine
repeating. I
also
think there
repeating.
is a
There is
problem
a
from
problem from
organizing.
organizing.
Might be possible.
Might be
Yeah,
possible.
that's the problem. I was
Sir, your
making
also
So
your
the
voice
your voice
also is
also
repeating.
is repeating.
my voice.
Yeah,
For
it's
me,
Yeah,
repeating.
it's repeating.
for me, your voice is okay. For the about the madam, it was breaking.
Okay,
Okay.
but my voice
But
is
my
repeating
voice
for
is
me
repeating for
also.
me also.
Yeah, somewhat better than somewhat better for your voice.
Sir, I
Sir,
hope you
I hope
Dr.
you
Salim,
Dr. Salim.
Yes, sir.
Yes, sir.
I think
I think
problem is
problem is
into
into
IP
IP
system
system
at the
at
unknown
the
user
unknown
side.
network side.
Yeah.
He has
He
he
has
has to
he has
shoot
to shoot
after asking the
after
distance.
asking the distance.
Okay.
In that case,
In
there
that
will be
case,
no
there will be
mistake.
no output.
Okay. First of all, I am using a IEEE 13 bus system.
okay,
Okay,
30 node bus
30 node
system.
bus system.
Yeah, 13 bus or 33 bus or 37 bus system. In
The
that,
same
The same
example sheet is
example sheet
present
is
in our
present in our
type sheet.
type sheet.
actually, ma'am, what happened? What is the document available in the Typhoon HIL is for not for the real time. It's
Okay.
been virtual and it is not real time. So what I was doing here is the coding is interfacing with the Typhoon HIL, and I'm using a real time simulation for that. So at that time, it was not supporting me. Like it says, the the switches should be less than 14 because the compatible of the every device, every HIL 404 is about to only less than 14, but mine was about 14. Like my getting is 16.
Okay, sir.
Okay, sir.
Is it
Is it
possible that we
possible
can
that we
connect
can
after
connect
this
after
session?
this session?
Yeah.
Sir,
How
you can
do?
You
raise
can
your
raise
things,
your
we will
things, we
check
will
it
check
once,
it once,
and then we
and
can
then we
connect
can
to the
connect to the
individual teams
individual teams,
2-person meeting.
2-person meeting.
That would be
That
Yeah.
would be
better, and you will
better,
be
and
able
you will
to
be able
your model
your
also
model also
right in that
right
respect.
in that respect.
Yeah. I can. How can you please give me the how to connect to the later section and information
Mail
in
ID
chat?
Mail ID
Yeah.
was
was
asking,
asking,
not after
not
your
after your
KP at the
KP
rate
at the rate
fast.com. You can
you
mail
can
me
mail me
there. It will
there, and
Quartz.com.
it is
your contact
your
also
contact
there.
also there.
Mm-hmm.
So
So
WhatsApp number
WhatsApp
that
number
we
that
can send
we
you
can send
something
you
reply
something
through
reply
mail
through
or
mail
for connecting
or
it.
connecting it.
Okay. Uh, it's kpquartz.com.
KP at the
KP at
rate
the rate
QUARBG.com.
QUA. Yeah,
QUA.
I
Yeah,
think
I think
separately from the
separately from
type
the type
teams,
teams,
Spark team
Spark
could
team
issue
could
mail ID.
sliding.
putting the KPI without format in chat box.
Oh yeah, chat box.
Okay, sir.
Uh, Thank you very much, ma'am. Thank you very much for your help.
Thank you. Thank you, sir. So, Vivek sir, if there are no more queries, can we wind up?
Okay. So if there is no,
Participants you have still, so we can stay, otherwise we can wind up.
Madam, one more question. How do we get when we get the recording new sections videos?
So,
we
could you
will
please
let
increase the voice? I'm getting
we will let you know